a switch. Okay, an electrically controlled switch. Doing all right? Okay. So the VI curves for this, get a family of curves here. This is called, this symbol here, it's a 3-terminal device. This is, because of the orientation of my arrow there, this is an NPN, not pointing in transistor. And so we get a family of curves here. This is the voltage collector to emitter, the collector current. This is VCC here. This is a resistor. What if there's absolutely no current going in? What's the voltage from the collector to the emitter? Okay, no current going in. Anything exciting going on here? So we can model it as what? Open circuit. So it'll be VCC. If this guy were to go to absolutely zero, if we could dump enough current in there that we could drive this thing to 0 volts, actually we're only going to be able to drive it to about 0.2, 0.3. Somewhat depends upon the size of the transistor. Hockey puck size transistors have much larger saturation voltage, around 1 volt or so. Tiny transistors, 0.3. So, but assuming that we could drive this to 0, how much current would flow? So 0 collector to emitter voltage, how much current? VCC over R. You understand that that gives you a load line there, just like I drew a load line over there on our diode circuit. Right? And so where you operate on this load line depends upon how much current you're dumping in. If I dump in absolutely 0 base current, I'm operating here. If I drop in a whole bunch of base current, I'm operating over there. Everybody all right with that? Yeah. Okay. So this is a BJT transistor. Now let me show you a MOS transistor. What have you noticed that I've done here? I've kind of messed around with the N's and the P, right? Okay. So this is what's called an NMOS, or an N channel. Okay. Our symbol for it looks like this. So here's the gate, this is drain, source. I'm going to put a layer here of silicon dioxide. What is silicon dioxide? Glass. It is glass, an insulator, conductor, semiconductor. Insulator. It's an absolute insulator, right? You're not going to get anything through glass. Okay, so then what I'm going to do is I'm going to put a chunk of aluminum up here. I'll put a chunk of aluminum here and a chunk of aluminum here. So once again, if I were to take and do this, how much current would flow? So I've taken a battery and a resistor and put it between my drain and source. What's going to happen? Silence is right. Nothing. You understand that you still have what? Diodes, 2 diodes that are back to back, right? And one of those diodes is going to be opened up. So nothing exciting is going to happen. Everybody okay with that? What happens if I now start putting positive charges here on that aluminum plate? What do you suppose is going to be attracted to the underside of the glass? Negative charges. Ooh, cool. What wants to flow in these end sections? Electrons. And now you start putting in some electrons there. Do you now see that you can have current flow between the drain and the source? So if I put a little bit of charge, a little bit of current. The more charge I put between the gate, so what I'm going to, this is my source here, I'm going to put a battery here, like that, and now I can open up that channel. An N channel is induced, and current can start to flow. So what I'm going to make with this is a switch. And this, I've made an invert gate here. If I apply 0 volts here, this guy is off, and my V out would be what? VCC? And if I put 5 volts or VCC over here, then what I get out is 0 volts. So I've made myself a switch here, or an invert gate rather.
Is that like a little triangle, or is it just a big block?
Where that guy there, that's our symbol for the N channel device. So this thing here you're talking about?
Yes.
That models what's going on here. Okay. Another symbol that we're going to use for that looks like this. Okay, where the arrow is pointing out, very much like it did with the NPN transistor. Everybody all right? Okay. What do you suppose would happen if you reverse the P and the N materials? You get exactly the same type of device, but it's now going to be a P channel.
Would you have to reverse the positive and the negative field up at the top?
Yeah, the current's going to go kind of in the opposite direction. We'll talk about that. So this is where I'm going to leave it. Now I passed around a, this is the sheet for the 74LS00. What kind of a gate is the 74LS00?
2 input and
Quad, 2 input, and gate. Is that all right with everybody? All right. So you can take a look at some of the parameters there. What do you